Welcome to the EEE360 video for experiment number 10, the alternator under load. For this lab, we'll be using the following components. We're using the power supply, the AC voltmeter, the resistive load, the DC ammeter, the AC ammeter, the synchronous machine, the direct current machine, and also the handheld tachometer. Here's a close-up of our motors with the front panels removed. On the left, we have the direct current machine, and on the right, we have the synchronous machine. And we'll notice that these are coupled with a belt, so as we turn the rotor on the DC machine, it'll make the rotor on the synchronous machine turn as well. In conventional generators, the rotor is turned by a steam turbine. But again, in this lab, we're just going to be using the DC motor to turn the rotor of the synchronous machine. And now we're ready to make our connections. First, we're going to set up the power to the direct current machine. So we're going to go from the fixed DC output to one side of the armature winding. And now we need to connect up the DC shunt winding. And we need to make an interconnection here in order to get this connection properly made. Now we're going to make the connections from the neutral side of our fixed DC power supply to the other side of the armature winding. And now we're going to make the connection to the other side of the shunt winding for the DC motor. Now we have our DC motor properly set up. Let's provide DC excitation to our alternator. First, we're going to go from the variable DC power supply through the DC ammeter so we can measure our excitation current. Now we're going to make the connection to the rotor winding. So this is how we're going to provide our DC excitation. We're going to do that into the rotor winding. And now we're going to connect the other side of the rotor winding to the neutral on our variable DC power supply. Now let's connect the output of our synchronous generator. First, we're going to connect the windings in Y, the stator windings in Y. So we're going to short out one side of those windings in order to provide the neutral point of our Y connection. Now let's connect our outputs from our power that we're going to be generating. We're going to go for A phase. We're going to connect through the ammeter. And from the ammeter to one of our resistors. Next, we'll connect our B phase output from our generator directly to the B phase resistor. And finally, we'll connect our C phase output from our alternator / generator to the last resistor. We want to connect this load in Y, so we're going to short the neutral point of our resistors. And the last connection that we want to make, we want to measure the line-to-line voltage of our output that we are generating. So this is the line-to-line voltage between A phase and B phase, the output of our generator. Now we have all of our connections properly made. Now we're ready to energize our circuit. We can see that as soon as we energize our circuit, the motor starts turning. We now need to adjust the speed of the DC machine. We're going to do a close-up of that so you can see how, as we adjust the armature excitation of the direct current machine, how that changes the speed of the motor. And now we're ready to check the speed of our DC motor. We can see that right now the motor is turning way too fast, so we're going to adjust the potentiometer to adjust the excitation of the DC motor. We're going to adjust that till we get really close to 1800 RPMs. And you can see here that we are now very close to 1800 RPMs. And now we're ready to start producing electricity with our generator. In order to do this, first we close the switch so we can start providing DC excitation. We're going to turn up the voltage on our variable DC power supply to increase the DC excitation until we get to 208 volts line to line on our output. And you can see here we do indeed have 208 volts line to line. And now students, it is your turn to go into the lab and practice this and other experiments as outlined in your laboratory manual.